So I had this question, which is like sort of in general. Like every team uses some part made of aluminum with some complex geometry. I'm curious why no team that I interviewed yet has made like a mini foundry to build aluminum cast things.
I was thinking a bit about that because I'm mainly focused on additive manufacturing, and I'm trying to explore the benefits of both commercially available additive manufacturing and the high-end additive manufacturing, which is also my part-time job. But I was thinking about using PLA in the lost cast method, in which you manufacture the final part in PLA, 3D print it, make a cast around it of something, and then burn the PLA out. So then you can cast the liquid aluminium into that and get the final shape. So maybe for next years, we want to incorporate something like that. But right now, we are really trying to succeed. And by succeed for us, right now, it means to compete at Europe, to be able to present reliable power source or propulsion unit, and deploy our chute, because we got that last year not many teams were successful in that.
So basically it means as simple as possible this year, and we are going to get crazier or crazy in the following years. And by the way, doesn't it look cool when you have a strange looking aluminum part? I think that's the reason.
When it comes to difficult shapes, we want to incorporate the additive manufacturing as much as we can. So maybe we would try to get the aluminum 3D printed part.
So what you said before, like how do you burn out the PLA and what do you make the mold out of?
Well, you simply put the mold in the heat, in the oven or stuff like that.
Oh, so you melt it out?
Yeah, exactly.
And you make the mold out of what, like clay? You have some refractory material, cement?
There's some kind of specific material. I think it's some kind of clay or ceramics. I'm not so sure about that, about the specific. I know it has some specific name, but yeah, I think it's some kind of ceramics or stuff like that. Actually, using this lost cast method, it is pretty common. The only innovative, let's say, because many people are already doing that, thing is 3D printing the initial model.
You might be interested in Greensand casting.
Greensand casting. Okay, I'll have a look at that.
It's if I'm not I'm not being confused with another name. If I understood correctly, you have like two boxes. You can do it with two boxes. You have a mixture of sand and clay with some water. Then you can have a shape like a PLA mold. You put it in between the boxes. You press. Then you remove the boxes. You remove the pot, and you've got like a two-part mold. Then you can, like using a finger, you can make a canal for the aluminum to get in. You close the boxes together, you pour the aluminum, then you let the aluminum cool, you open it, you cut out and sand the additional parts, which you don't want, where the aluminum was coming in, and then you have an aluminum part.
Yeah. Sure, we have such technology here at the university.
Yeah, we actually tried that a bit.
We tried. Yeah, we tried during our courses.
You made a furnace?
No, we were able to make the mold and try to cast something ourselves.
Without the furnace. There wasn't any need to use the furnace. It was just somehow using the pressure. You just made it, let's say, more... you just made it fixed, kind of, and... hard, and then you just poured the aluminum in, and that was it.
No, I mean, like, how did you melt the aluminum?
Yeah, the teachers did that because
exactly.
We have huge laboratories when it comes to that.
Sorry, I thought you meant the furnace for baking
the mold.
The mold, yeah, correct.
We actually have pretty good laboratories when it comes to this because we are able to use the lathe a bit. we were able to do some, blacksmith. Really basic. It's harder than it looks. On the YouTube videos, it's always pretty much satisfying, but we are just trying to get some triangular shape, and it was hard as hell. We had like 60 minutes for that, and none of us was able to make it.
Well, we were, but it wasn't that beautiful.
Nice. Yeah.
You mean like with the hot iron or steel?
Correct. Yeah. Sure.
I know you can practice your blacksmithing skills with a mixture of clay and oil. If you cool it down, it's got a similar hardness and viscosity, I think, to hot iron. So you can practice your blacksmithing on that, and then when you know how to blacksmith, you can do it on the real iron.
Yeah, I was just searching for the lost wax casting, which we discussed earlier, and yeah, it's the mold is made out of plaster or ceramic shell.
Yes. Because I know that if you just use clay, the clay has a tendency of breaking when heating.
Yeah.
Also because I think, I don't know if it's like difference in temperature and it being hot, meaning that the outer part expands and the inner part is smaller than the outer part. Something like that. Or maybe it's just that there's some water inside and when you heat it, it boils and it explodes. Anyways, I've tried to make some crucibles out of clay and a couple of them exploded.
Well, you survived. So
well, not like it wasn't a powerful explosion. It was like pop, and it flew like.
That's not explosion.
Yeah,
I mean,
when you're talking about explosions, I imagine exploding engines and just dangerous stuff.
I think once the pot flew like 2 meters, but no.
Wow.
Oh,
it's actually
the
pretty long for that.
What were you doing your blacksmithing for?
It was just.
We just had this class which aimed at learning us the basic stuff of designing, of manufacturing. Yeah, so when we design something, we at least a bit know how much work is behind that to make it work, and the specifics of these techniques.
It just show us different technologies of how we can manufacture our CAD models, let's say, or just our ideas. Because it's not just blacksmith approach, but also different techniques. So we were just shown, I would say almost all of them, except for probably additive 3D printing, metals. At least I don't remember any examples of that during our
No, we weren't
yet.
shown a bit of additive manufacturing, but when it came to classic manufacturing, it was pretty good actually, because once you try it, you have some stuff in your mind when designing something which needs to be made. For example, if you're making something which needs to be casted, you have to separate it somehow from the mold. So you design it with this thought in your mind. You have to make the shapes so you can pull it out of the mold.
If you make it out of a plaster and you put aluminum inside, can't you like bang it with a hammer and break all the plaster?
Yeah. For this method, yeah. But if you want to make something in serial manufacturing, you just can't break each mold. You have to select different type of casting.
I guess Greensand casting would it being sand.
Yeah, exactly. This is one of the cheaper methods. But that's exactly what you need to have in mind. Like you have to design it in such shapes that you can put it out of the sand form or sand mold without breaking it.
Oh yes, because if you have like a bottle, then if you put it inside, you need to fill it up with sand. But then when you remove the bottle, the sand can't stay inside.
Exactly.
I guess you can't make a bottle with the plaster either.
Yeah, for the bottle, it's a bit tricky.
I mean, you could do it, and then you surround it in plaster. Then you drill a hole, you melt it all out of the hole. Then you put the aluminum inside of this tiny hole, and then you destroy everything. I don't know how, and you have an aluminum bottle.
Yeah, exactly. This is the way how it could and should be done, I think.
Or you can make two halves and then just...
Yeah, but
Ooh.
with two valves, you wouldn't have the inside of the bottle.
Yes.
Or you could have like the outer part in two parts, and then you can put a bit of aluminum, and then you can roll it really fast, making this the centripetal or centrifugal force. I don't remember how it's called.
Yeah, centrifugal force is the correct term.
And it just spreads on these sides, and then you blow in cold air, you freeze it, and then you separate the two parts, and you've got an aluminum bottle.
Yeah, that's also possible.
Good work. But just feel free to try. That's exactly what we just support. Just dream and try, experiment, be curious. No limits. But yeah, I mean, really good luck with that.
Under advisor, please.
Thanks for joining me. It's been a pleasure interviewing you and talking to you.
Thank you for having us, and thank you for giving us the chance to share and also to talk to you, because it was really a pleasure to meet you. And as we already said, we will be really happy to meet you in person. If it happens in Europe or anywhere else, we're really happy to meet you in person.
Yeah, definitely. Thank you for that opportunity to talk to you. Thank you. Bye.
Thank you. Bye.
Bye.